Hi, Physics Boss Man here. Is it obvious when I'm wearing the hat from my favorite school? A lizard runs along the edge of a rectangular swimming pool of length 27 meters and width 21 meters. If it runs from one corner to the diagonally opposite corner in 30 minutes, what is its average speed? And part B, what is the magnitude of its average velocity?
God's
Help, you can do physics, boss, as you
You are created in God's image.
to be fruitful and multiply.
Fill the earth and subdue it.
Okay, so every good physics solution starts by interpreting the problem. So let's do that, and we're going to do that with a picture and by identifying the general principles. So we just draw a rectangular representing the swimming pool, and one side of the swimming pool is 27 meters, the other side of the swimming pool is 21 meters, and it's convenient to kind of draw the path of the lizard running around the edge of the pool, because we're also interpreting that it starts at one corner and it ends up at the diagonally opposite corner. And let's also draw the displacement vector, because we're asked to compute both the average speed and the average velocity, and the average velocity is going to have to do with the displacement vector, so it helps to put the displacement vector in there. And then we also want to identify the general principles of physics. And the principles of physics that are important in this problem, one is simply the definition of speed, or average speed if you will, and the other one is the definition of average velocity.
God has crowned you
You
with glory and honor.
honor to rule over his creation.
Creation.
Now, to develop, we usually make a bullet point plan on how we're going to get to our solution. So let's compute the total distance, and then from the total distance and also the time, we should also convert time to seconds. Oftentimes unit conversions pop up in our plan. And then we're computing the average speed. And then to get the velocity, because we're calling the definition of velocity, it's the displacement divided by the time. The total displacement divided by the total time would be the average velocity vector, but we need to compute its magnitude, so we're just going to compute the magnitude of the displacement vector d, and that's just the Pythagorean theorem. And then from there we can compute the magnitude of the average velocity, which I'll just use that symbol for.
Science is a gift from God,
To help us master nature,
but sin added thorns and thistles.
requiring the sweat of your brow to succeed. Okay, so E is evaluate or execute. And notice we don't start with formula roulette. What formula do I need? We think about what's happening physically and the important principles of physics before we start writing down formulas. But now in the evaluate stage, it's time to compute the total distance d. It's just the 21 meters plus the 27 meters is 48 meters. And then the average speed, we'll just give it the symbol S, is convenient. And so that's d over t. Oh, and we didn't convert the time to seconds. 30 minutes times 60 seconds per minute would be 1800 seconds. So this is 48 meters divided by 1800 seconds, and so that works out to be 0.0266 meters per second. Convert it to centimeters per second, take care of the significant digits, is 27 centimeters per second. And now the magnitude of the velocity
Learning physics
often requires prayer
as we submit
to Jesus Christ
as risen.
as risen King of Kings and Lord of Lords is the displacement over the time. So we need to compute the magnitude of the displacement. And that's just Pythagoras. Is the square root of the sum of the squares, 21 meters, quantity squared, plus 27 meters, quantity squared, divided by the same 1800 seconds. Punch all that into your handy dandy calculator, and it's 0.019 meters per second. Convert to centimeters if you like. 19 centimeters per second. Alright, so that's the average speed. That's the magnitude of the average velocity. Now, in our assessment,
We reign by surrender.
we reign by surrendering to Jesus and praying for our daily bread, which includes success.
In our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor. Okay, in our assessment, we take a couple of approaches. Well, does the answer basically make sense? In other words, are we expecting that 27 centimeters per second is about how fast a lizard can run? And if you've ever seen a lizard run, 27 centimeters is really close to a foot. 1 foot per second kind of makes sense for the speed of a lizard. So let's go ahead and check that off, that it makes sense. Just in terms of the magnitude and what we've observed in life about lizards. But let's take another approach, a little more quantitative approach to this assessment, would be to do the calculations backwards and say, okay, well, distance is speed times time. So let's double check our speed here. Distance is speed times time, so let's double check our speed here was 0.0266 meters per second times the time 1800 seconds, and that does turn out to be, that gives us a 48 meters back. So that's a simple common sense double check. And doing the same thing for velocity, that the magnitude of the displacement vector should be equal to the magnitude of the velocity times the time. So punching in our numbers is 0.019 meters per second times the 1800 seconds, and so that gives us 34.2 meters, but we don't really have anything to compare that to because we skipped the step of computing the displacement as a separate step from the Pythagorean theorem. So let's go ahead and do that. 21 meters squared plus 27 meters squared, and indeed that does give us 34.2 meters, or something very close to it once you also account for the rounding issues and such. So that one checks out, passes our assessment.
Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom.